Ahead of you, the stars begin to bend, not twinkle, not fade, but curve, as if the night itself has been pulled around something your eyes cannot properly accept. There is no roaring vortex, no cosmic whirlpool, no giant mouth opening in the dark. Only a region of space so black, so still, and so wrong that every distant point of light seems to lean toward it. You keep drifting closer, and with every silent second, the universe looks less like a sky and more like a warning. A black hole is one of the strangest things nature has ever made. It is not an object in the ordinary sense, but a place where gravity has become so extreme that beyond a certain boundary, nothing can come back out, not even light. Around it, space does not behave normally. Distances become deceptive. Time itself begins to separate into different stories depending on who is watching. And if you were unlucky enough to fall toward one, the experience would not be dramatic in the way fiction imagines. It would be stranger, quieter, and far more unsettling. Modern physics can describe much of this journey with surprising confidence. Einstein's theory of general relativity tells us how mass bends space and time, and black holes are among its most powerful predictions. Astronomers have watched stars orbit invisible heavy companions, traced hot matter spiraling inward, and even captured images of the glowing regions around supermassive black holes. Yet some parts of the story remain uncertain. We understand the approach. We understand the point of no return. What happens in the deepest interior is where our best theories begin to break apart. That is what makes this question so compelling. What if you fell into a black hole? Not as a metaphor, and not as fantasy, but as a serious thought experiment built on real physics. What would you see as the light around you twisted? What would happen to your body, your sense of time, and your final connection to the rest of the universe? And would every black hole kill you in the same way? Or does the answer depend on the kind of black hole waiting in the dark? This is worth taking seriously because the differences matter. A small black hole and a supermassive one do not offer the same ending. The view from your perspective and the view from far away are not the same. Even the moment you are truly lost may not feel like a moment at all. So settle in for a long descent through warped light, broken clocks, collapsing horizons, and the last frontier where science still speaks in careful, incomplete sentences. If you enjoy journeys like this, take a moment to like the video, subscribe, and tell me in the comments where in the world you're watching from tonight. Now, dim the lights, loosen your grip on the modern world, take a breath, and let the stars begin to bend. The first change is not fear, it is confusion. The dark place ahead does not look like any danger the human mind was designed to recognize. It has no flame, no teeth, no storm front, no wave crest, nothing that carries the old language of survival. There is only a silence so complete that your own thoughts seem louder than the universe around you, and a shape that is not really a shape at all. The blackness in front of you does not sit against the stars the way a planet would. It unsettles them. It rearranges them. It makes the sky look as if it has been folded around an absence. At first, you may think you are only seeing badly. Distance in space is already difficult for the eye to judge, and there is nothing nearby to provide scale. But the distortion does not go away. It becomes cleaner the longer you look. A thin crescent of stars, which should be straight from your angle, appears bowed. A familiar pattern of distant lights seems duplicated and smeared. The darkness remains perfectly black, And yet, around it, the universe becomes busy with impossible geometry. Something is bending the paths of light itself. That is the true beginning of a black hole encounter. Not a dramatic fall through a visible tunnel, but the moment when ordinary seeing fails. A black hole is dark for a simple reason. If no light can escape from within its boundary, then no image can come directly from it. You never see the black hole in the way you see a moon or a mountain. You see what it does to everything around it. You see the surrounding stars warped into curves. You see any nearby gas heated into a furious glow. You see motion, heat, and broken symmetry. The central object remains hidden, not because it is small or far away, but because the rules of escape have ended there. The boundary where that escape ends is called the event horizon. It is not a wall made of matter, and it does not shimmer like a shield. Nothing special marks it in empty space. You could drift toward it with no cosmic signpost warning you that you are close. Yet, it is one of the most profound boundaries in physics. Cross it, and every path that still counts as the future leads deeper inward. Remain outside it, and, at least in principle, there is some route, however difficult, by which signals can still reach the wider universe. That is why the event horizon matters so much. It divides places where return is still possible from places where return has ceased to mean anything. Before you ever reach that invisible frontier, the mind begins making bad comparisons. Perhaps this is a drain, you think, a kind of sink in the fabric of space that pulls everything around it into a central throat. Popular imagination has loved that image for decades because it is vivid and simple. But nature is usually stranger than the simple picture. A black hole does not reach across the galaxy like a cosmic vacuum cleaner, dragging in every passing star and planet. From far enough away, it behaves like any other mass. If you replaced the sun, impossibly and instantaneously, with a black hole of the same mass, Earth would not be yanked from its orbit. It would continue circling along the same path. The catastrophe would come from the loss of sunlight and solar wind, not from some sudden gravitational ambush. That idea is worth lingering on, because it strips away one myth and replaces it with a deeper unease. The danger of a black hole is not that it cheats gravity. It obeys gravity with such perfection that only proximity reveals how extreme the situation really is. Far away, a black hole can be almost modest. Close up, it becomes a place where ordinary intuitions fail, one after another. There is no dramatic threshold visible from a safe distance. No universal sucking force announces itself. The real hazard is that space can remain calm while the conditions within it become irreversible. So, if you are falling toward one, something specific has already gone wrong. You did not merely wander through empty interstellar darkness and get plucked out of safety by invisible hands. You approached. Perhaps your spacecraft lost power near the center of a galaxy. Perhaps you were orbiting a dense, dead star and discovered too late that its companion was a collapsed remnant. Perhaps, in a more careful scientific scenario, you are not a person in an exposed suit at all, but an observer inside a vessel, instruments still working, watching your trajectory decay as the mathematics becomes merciless. However the story begins, the essential point remains the same. To fall toward a black hole, you must come close enough that your path through space no longer misses it. Orbital motion matters here. In the deep quiet of space, falling is often not a straight plunge. It is a curve, a balance, a compromise between forward motion and inward pull.
Planets fall around stars. Moons fall around planets. Even gas and dust near a black hole can spend a very long time circling rather than dropping directly in. If your path sends you around the black hole with enough sideways speed,
you may enter an orbit instead of a descent. If that orbit is high and stable enough, you might survive for a time. If it is lower, or if other forces steal your energy, the circle can tighten. Each pass brings you closer. Each loop can become smaller than the last. In that sense, doom may not feel like a single decision point. It may feel like a quiet narrowing. This is another reason black holes are so unnerving. They do not always kill with spectacle. Sometimes they kill with mathematics. If you are on the wrong trajectory, and if nothing corrects it, your options dwindle smoothly. The sky may still look magnificent. Your instruments may still speak calmly in numbers and graphs. Your heartbeat may still be ordinary. Yet somewhere in the equations, the possibility of escape is already shrinking. That kind of danger is difficult for the human mind to feel properly because it does not resemble predators, storms, cliffs, or fire. It resembles certainty, becoming visible one decimal place at a time. And still, the visual world keeps changing. The black region ahead now appears ringed by strange brightness. This is not because the black hole itself glows. It is because light from behind it is being bent around it, redirected toward you along curved routes. In a gentler gravitational field, this effect can create arcs or multiple images of distant galaxies, a phenomenon astronomers call gravitational lensing. Around a black hole, lensing becomes dramatic. Light that would have traveled past in straight lines is forced into new paths. Parts of the sky slide inward toward the darkness. The same star field may seem to appear in more than one place. The universe begins to look as though it has been reflected in a sphere made of warped glass. Except the center of the sphere is not reflective at all. It is pure removal. There is a simple beauty in this, and beauty can be dangerous because it calms the instinct to flee. The ring around the darkness may look almost delicate. The contrast between black center and bright distortion can seem artistic, like an abstract painting stretched across eternity. But the elegance comes from light barely surviving a close pass. You are not watching decoration. You are watching space-time show its curvature. Every bent line is evidence that the geometry around you has become extreme. If the black hole is quiet, with no large amount of matter actively falling into it, this visual warping may be the cleanest sign you get. A truly isolated black hole would be dark except for the background universe it distorts. In that sense, it could be almost invisible until you were close enough for the sky itself to betray it. But many black holes are not so tidy. Some live in busy environments, feeding from nearby gas clouds or from companion stars. Some sit in galactic centers, surrounded by matter spiraling inward over immense timescales. In those cases, the invisible object announces itself with violent light. Matter falling toward a black hole does not usually drop straight in. It collides, swirls, compresses, and forms an accretion disk, a flattened structure of gas and plasma orbiting at enormous speed. Friction and compression within that disk can heat it to extraordinary temperatures. Depending on the black hole's size and feeding rate, the disk may radiate across many wavelengths, including visible light, ultraviolet light, and powerful X-rays. The region can become one of the brightest things in its entire galaxy. So there is a cruel irony here.
The black hole itself remains black, but the process of dying near it can be blinding. If you were unlucky enough to approach an actively feeding black hole, this surrounding environment might be the true killer. Long before any horizon is crossed, radiation could damage electronics, shred molecules, and make human survival impossible. A person does not need to touch the surface of a star to be destroyed by its heat, and the same is true here,
though the mechanism is different. The threat comes not from a solid object, but from matter tortured by gravity into a luminous furnace. The space around the hole can become less like empty vacuum and more like the interior of a machine running far beyond anything living tissue can endure. There is also the matter of jets, which makes the scene even more severe in certain cases. Some actively feeding black holes launch narrow beams of high-energy particles from regions above and below the disk. These jets can extend across enormous distances, driven by complex interactions between rotating space-time, magnetic fields, and infalling plasma. Not every black hole produces them, and the details remain an area of active study, but when they are present, they are among the most energetic structures in the universe. To drift directly into such a beam would be catastrophic. Yet even here, precision matters. The jet is not the black hole itself. It is part of the surrounding engine, another reminder that the environment near a black hole can be more immediately deadly than the final descent. So the question slowly changes shape. What kills you first? Not every black hole offers the same answer. Before you can understand the fall, you have to know the kind of object you are falling toward. The phrase black hole covers a vast range of sizes. Some are only a few times the mass of the sun, born when massive stars exhaust their fuel and collapse under their own gravity. Others are millions or billions of times more massive than the sun, sitting at the centers of galaxies like colossal hidden anchors. Between these extremes, astronomers suspect there are intermediate black holes, though they are harder to confirm and less well understood as a population. The label is the same in each case. The experience is not. A stellar mass black hole is compact in a way that almost defies instinct. A few solar masses can be packed into a region only tens of kilometers across. The event horizon of such an object is tiny by cosmic standards. That means the gravitational gradient near it can become ferociously steep. Move a short distance closer, and the pull increases enormously. These are the black holes that tend to embody the nightmare people imagine most easily. If you approach too closely, the difference in gravity between your feet and your head can become lethal before you ever cross the horizon. The smallness of the object is what makes the violence near it so sharp. A supermassive black hole, by contrast, is a different kind of horror. Because it contains so much mass, its event horizon can be vast, larger than the orbit of Mercury in some cases, far larger in others. Oddly, that larger size makes the gravitational difference across a human body at the horizon much less severe than it would be near a small black hole. In plain terms, a supermassive black hole can allow you to reach the boundary of no return before tidal forces become immediately fatal. The result is not safety, only delay. But delay matters. It means there are scenarios in which the most irreversible moment in your life arrives quietly, without your body instantly announcing what has happened. That contrast is one of the most haunting truths in this entire subject. The smaller black hole is, in some ways, the more brutally physical danger at close range. The bigger black hole is, in some ways, the more philosophically disturbing. One can tear you apart outside the horizon. The other
can let you slip through the horizon, still thinking coherent thoughts, still seeing the distorted universe around you, still unaware on a sensory level that you have crossed a line from which no signal can ever return. If the mind were forced to choose, it might prefer the violent version, because violence at least declares itself. The quiet version is harder to bear. Imagine the most important boundary in your existence arriving with no color change, no thunder, no crack in the sky.
Imagine continuing to float, to breathe, to observe, while the rest of the universe has become unreachable in principle. That is the special cruelty of a large black hole. It does not need to frighten your nerves immediately. It is enough that the geometry has changed around you in a way your senses were never built to detect. By now, the darkness ahead occupies more of your vision, though saying it occupies space is not quite right. It seems to gather the surrounding sky into itself. Stars near the edge of the black region grow brighter in a narrow band as their light is focused. Others appear displaced from where they should be. The farther background does not feel far anymore. It feels unstable. If you were comparing the scene to anything familiar, a glass lens would be the nearest answer, but the comparison fails because a lens sits in space, while this effect comes from the structure of space itself. Your sense of direction starts to suffer. In everyday life, left and right feel dependable because the world around you offers so many fixed references. In empty space, references are already sparse. Near a black hole, they become treacherous. The sky is no longer a trustworthy map. Light that began on one side of the hole may reach you after curving around from another direction. One part of the star field can be stretched thin, another squeezed tight. The place ahead looks wrong, but so does the rest of the universe. That matters because danger is easier to confront when it is isolated. Here, even the background has joined the deception. For an outside observer looking at your ship from very far away, your approach might still seem almost ordinary for a while. You are just another small object following a trajectory, but subjectively, the environment is becoming less natural with every passing minute. This difference between the distant view and the local view is at the heart of black hole physics. Gravity does not only pull, it also shapes the passage of time and the paths along which light can travel. Two descriptions of the same event can remain consistent while feeling emotionally incompatible. Someone far away may describe a slow approach. You, inside the scene, feel the growing visual strangeness, the narrowing options, and the mounting certainty that geometry itself has turned against you. And yet, there is still no sense of being dragged by force. This is important. If you are in free fall, you may feel oddly weightless. Gravity is strongest precisely where falling becomes most inescapable, but free fall often removes the sensation of weight rather than increasing it. That is why astronauts orbiting Earth feel weightless, despite gravity still acting strongly on them. Near a black hole, if tidal effects are not yet severe, and if your craft is not firing engines, you may still feel no crushing force pressing you into the floor. The threat is written into motion, curvature, and future inevitability, not into an immediate bodily sensation. This gap between what is happening physically and what it feels like psychologically gives the whole encounter its eerie quality. The universe can be deciding your fate while your body remains calm. You might still be able to sip water from a pouch, still read values on a screen,
still watch the stars bend in silence. Only reason tells you that the comfort is temporary. Only the calculations tell you that a clean line between life and impossibility is drawing nearer. Suppose for a moment that you were approaching a black hole that is not actively feeding, one with no bright disk to warn you from afar. In such a case, much of the visual drama would come from the star field alone. The black center would grow, but not because it emits or reflects anything. Around it, there would be a region where light skims so close to the hole that it can circle partially before escaping. Photons could loop in complicated ways,
creating rings and echoes of the background universe. There is a threshold called the photon sphere outside the event horizon, where light can, in principle, orbit the hole. For a non-rotating black hole, that orbit is unstable. It is not a safe track for anything to linger on, but its existence helps explain why the visual scene can become so rich near something that is, in itself, perfectly dark. A rotating black hole complicates the picture further, though the basic emotional truth remains unchanged. Rotation twists the surrounding space-time, changing the exact locations of key boundaries and altering how matter and light behave near the hole. Real black holes are expected to rotate, sometimes rapidly. That means the exact view around one can depend on the angle of your approach and on the hole's spin. The ring of distorted light may be asymmetrical. The environment may be more violent on one side than another. Yet all of these refinements serve the same underlying fact. This is a place where gravity is no longer content to pull on objects. It also drags on the stage itself. The more you understand this, the more the old mental image of a hole becomes unsatisfying. A hole is usually thought of as a gap in something solid, an empty place where matter is missing. But a black hole is not absence in that sense. It is concentration. It is mass packed so densely that the structure around it acquires this radical property of one-way travel. The darkness at the center of your view is not empty space. It is the visible consequence of a region where escape has failed. In a universe full of glowing things, that kind of darkness has weight. Somewhere in your instruments, if you have them, numbers are telling this story with a precision the eye cannot match. Radiation levels, relative velocities, gravitational gradients, clock drift. Perhaps a model on a screen is estimating your distance from the event horizon based on the black hole's mass and your trajectory. Those numbers may remain calm even as their meaning becomes unbearable. This is one of the most unsettling features of good science. It can describe doom elegantly. The equations do not panic. The graphs do not tremble. They simply continue, line by line, converting the unimaginable into something measurable. And what they tell you is that the notion of a safe distance is not a simple sphere painted around the hole. Safety depends on mass, spin, radiation environment, and trajectory. Around some black holes, you could orbit for a very long time. Around others, local conditions would destroy you before any deep descent began. Around a supermassive black hole in a relatively quiet state, you might come astonishingly close while still having time to observe, think, and wonder. Around a smaller black hole, close approach could become physically fatal with terrible speed. The same title, the same question, opens onto very different fates. But fate is not only about the final outcome. It is also about when you first understand the nature of the place you are in. And that realization often comes through sight. The sky keeps curving. The central darkness becomes cleaner, more absolute, the kind of black no earthly night has ever shown.
Around its edge, the universe seems sharpened and destabilized at once. Familiar distances collapse into a single, impossible frame. Looking at it feels less like looking at an object than looking at a flaw in reality. This is where fear finally begins to take its proper form. Not fear of a monster rushing toward you, but fear of entering a region where the ordinary agreements between distance, light, time, and direction are being revoked. The black hole does not have to snarl. It only has to remain there, patient and mathematically complete, while the rest of the cosmos slowly twists to acknowledge its presence.
You can imagine now why early theoretical work on black holes felt so unsettling, even before there was strong observational evidence that such things existed. They were not merely dense remnants. They were solutions to the equations that seemed to carve out places where known physics produced one-way boundaries and hidden interiors. Over time, evidence accumulated. Stars near the center of our galaxy were observed orbiting an unseen mass so compact and so heavy that alternatives became difficult to sustain. X-ray binaries revealed invisible companions pulling matter from nearby stars. More recently, the Event Horizon Telescope gave us images not of the hole itself, but of the bright material and shadow-like region associated with supermassive black holes. The modern picture is not built on fantasy. It is built on light, motion, and patience. That matters because the scene you are imagining is not a myth placed in space. It is an extrapolation from real objects the universe appears to contain in abundance. We do not yet know everything about them. We almost certainly do not understand the deepest interior correctly. But the approach, the visual distortion, the gravitational logic, and the role of the event horizon all rest on foundations that are remarkably strong. The speculative part is not whether black holes exist. The speculative part is exactly how a conscious fall would feel from the inside, especially once the known descriptions run out. And so you continue inward through the clean, cold distortion. The black region is now large enough that it no longer seems like a feature of the sky. It is becoming the frame through which the rest of the sky is interpreted. The stars along its edge stretch into a luminous border. Those farther away seem to lean in subtle ways, as if even untouched space now remembers the curve nearby. There is no sound. There is no wind. The only motion is the one you are already committed to. If you still hope for some hidden rescue, orbital mechanics offers one last, harsh lesson. In ordinary gravity wells, you can always imagine burning fuel, changing direction, buying back some margin. But all such possibilities depend on when you act. Act early enough, and trajectory is negotiable. Act too late, and there is not enough energy, not enough time, not enough room in the geometry to rewrite the story. Long before a black hole kills you physically, it can kill your set of options. That may be the most chilling part of the approach. Death does not begin at the moment a body breaks. It begins when futures quietly disappear. There is still a difference, at least, between disappearance and destruction. You remain outside the event horizon. Signals from you could, in principle, still travel outward. A distant telescope could still collect light from your craft. A radio message could still be sent. A course correction, if somehow strong enough and timely enough, could still matter. This is why the region just outside the horizon carries such emotional weight. It is the last place where the old logic of return has not yet been abolished. It is not safe. But it is still recognizably part of the shared universe, and that is precisely why the view becomes so difficult to bear. Every visual cue suggests that you are looking at something beyond the ordinary world.
Yet, technically, you are still in it. The familiar and the impossible overlap. The stars are still there, but misbehaving. The darkness is still ahead, but not an object you can point to in the normal sense. Time still feels personal and steady, but you know it is beginning to part company with clocks farther away. This threshold region is where the universe remains understandable enough to be terrifying. Soon, the question will no longer be what you are seeing from outside. Soon, it will become a question of what your body can endure, what clocks in different frames can agree upon,
and whether crossing the most important boundary in the cosmos feels like anything at all. For now, though, the sky is still speaking in curves and rings, the last light of the larger universe still able to reach you, even as it arrives bent, delayed, and quietly transformed. This is why the mass of the black hole matters so much. The size of the event horizon grows in direct proportion to mass. Double the mass, and the characteristic radius doubles. Make the object millions of times heavier, and the horizon becomes correspondingly vast. But the force difference across a small body near that horizon does not grow the same way. Spread the horizon outward far enough, and the gradient there softens. This is the paradox that makes supermassive black holes so eerie. They are greater in scale, yet gentler at the threshold. Their interiors remain fatal, but they can admit you with deceptive calm. Astronomers first came to appreciate black holes not by watching things vanish, but by noticing what surrounding matter was forced to do. In binary systems, a visible star can orbit a dark companion too massive and too compact to be a white dwarf or neutron star. Gas stripped from the star can form a bright disk, revealing the hidden object through its appetite. At galactic centers, stars move under the influence of enormous, invisible masses packed into astonishingly small volumes. The motions are not guessed at loosely. They are measured over years and decades. Bit by bit, the orbital tracks build a case. There, where nothing visible seems sufficient, something immense is holding court in darkness. Perhaps the most deceptive word in this subject is fall. On Earth, falling means giving yourself to a direction that is obvious and immediate. You feel your stomach shift. You feel the floor vanish. Air rushes past. Near a black hole, especially before tidal forces grow severe, fall can be much more abstract. You may feel suspended while your trajectory changes irrevocably under you. Your vessel, if you have one, may be gliding through vacuum with no internal sign of descent. Only the growing distortion outside and the logic of your instruments reveal that you are not merely traveling through space. You are being carried deeper into a region where the concept of outside is thinning. There are orbits, however, and they deserve respect, because they show that black holes do not simply erase structure around them. Far from the event horizon, stable orbits are possible in much the same way they are around other gravitating bodies. But as you move inward, the range of stable motion shrinks. For a non-rotating black hole, there is an innermost stable circular orbit, often called the ISCO, inside of which circular motion cannot remain steady. Matter there tends to plunge inward rather than circle peacefully. This boundary is not the event horizon, but it often marks the practical edge between enduring motion and final descent for accreting gas. In a more narrative sense, it is another of nature's quiet thresholds, another place where options narrow before they vanish entirely. If you imagined yourself initially passing the black hole at a safe distance,
even that safety would depend on precision. A tiny change in velocity, a small loss of energy through interaction with gas, or a long sequence of close passes could gradually bring you inward. In astrophysical systems, matter does not generally enjoy perfect, frictionless conditions. Gas rubs against gas. Magnetic fields rearrange momentum. Radiation carries energy away. Over time, circular motion can become spiral motion. A disk is born from this compromise between orbit and surrender. Seen from afar, an accretion disk is almost serene, a flattened ring of light around darkness. Seen as a physical process, it is a slow negotiation in which matter gives up its angular momentum and descends toward oblivion. That descent can produce some of the brightest, persistent sources in the sky.
The innermost parts of accretion disks around stellar black holes and supermassive black holes alike can reach temperatures that force atoms apart and create plasma of staggering energy. The light emitted from these regions tells astronomers about the black hole's feeding rate, spin, and surrounding structure. In some systems, variability in brightness reveals turbulence and instabilities in the flow. In others, broad emission lines betray matter moving at speeds that are significant fractions of the speed of light. If you approached such a disk in person, you would not need to understand spectroscopy to know you were near something hostile. The brightness alone would carry the message. The trouble is that some of the most important black holes in the universe are not blazing like this all the time. Some wait in comparative quiet, allowing geometry rather than glare to tell the story. Quiet does not mean harmless. It means the danger is cleaner. The lensing becomes easier to imagine because fewer distractions crowd the scene. You might see the black hole's shadow-like region surrounded by a narrow halo where bent light piles up. The exact size of this dark region is not simply the size of the event horizon, because the paths of photons near the hole are distorted in ways that enlarge the apparent darkness. What you perceive visually is shaped by where light can still reach you from and where it can no longer escape the neighborhood in your direction. In modern black hole images, this is why the central dark patch and the glowing ring around it have such strange authority. They are not artists' symbols. They are maps of light under extreme rules. This is one of the reasons black holes feel like natural machines for producing philosophical unease. Even before questions of the interior arise, they disturb the ordinary relationship between seeing and knowing. Under normal circumstances, the light reaching your eyes gives a manageable picture of where things are. Around a black hole, that relationship frays. The star you think is off to one side may be visible only because its light wrapped around from another direction. The black region may look like a hole punched in the sky, when in truth it is an absence defined by escape conditions. You are still using eyes evolved for African plains and forest edges to interpret a scene built by general relativity. And understanding does not make the approach easier. It may make it worse. A person who knows nothing of black holes might misread the danger until the end. A person who understands the basics can watch each stage for what it is: the enlarging dark center, the compressed ring of background light, the possibility that what looks beautiful is simply a map of escape routes closing, the knowledge that if the hole is active, the surrounding brightness is not a beacon, but a furnace, the recognition that a small black hole and a giant one promise different openings to the same final outcome. Knowledge turns the scene from mystery into impending fact, and fact can be colder than mystery. You continue inward anyway.
The stars are no longer just bending. They are beginning to crowd the edge of the darkness in ways that make the whole sky feel strained, as though the universe were being drawn across a curve too tight for it. Ahead lies the silent boundary you cannot see directly. Outside it, the old rules still function. Inside it, the word return will lose all practical meaning. Between those two realms, in this narrowing and lucid distortion, you are still close enough to observe and still far enough to think, which is perhaps the last true luxury the black hole will allow. That luxury begins to narrow the moment gravity stops treating your body as a single thing. Until now, the black hole has mostly announced itself through vision, through distorted light and disappearing options. Soon, it begins speaking a more ancient language,
one every living creature understands without needing astronomy. The pull on one part of you is no longer the same as the pull on another. Space is still silent. Your nerves still wait for a jolt that never quite comes. Yet the geometry around you has become steep enough that even a small difference in position matters. What matters most is the distance between your feet and your head. Near any gravitating body, the closer part feels a slightly stronger attraction than the farther part. On Earth, the difference is tiny. In ordinary life, it is too small to notice. Near a compact black hole, it can become the whole story. If your feet are closer to the center than your head, they are pulled more strongly inward. At the same time, the parts of your body extending sideways are squeezed together because every line of fall converges toward the same destination, stretching in one direction, compression in another. This is the tidal effect in its most merciless form. The popular name for this process is spaghettification, memorable enough that it has survived the leap from technical explanation into the wider culture. The word is vivid, almost playful, but the reality it describes is not. Tidal forces do not tear a body because the black hole is hungry or because a hidden wind is pulling on loose fabric. They tear because the gravitational field changes so sharply across a short distance that no material, however strong, can keep all its parts moving together. Flesh fails. Bone fails. Metal fails. Molecules themselves are asked to endure a difference in acceleration that grows beyond any structure built by chemistry. This is why a small black hole is, in some respects, more immediately cruel than a giant one. Near a stellar mass black hole, the event horizon lies so close to the concentrated mass that the gradient there can be enormous. Long before the horizon itself reaches you, the tidal difference from foot to head may already exceed what a human body can tolerate. There is no need for drama in the cinematic sense. The destruction is mechanical and absolute. A person falling toward such an object does not reach some mysterious invisible boundary intact and then perish in a flash of cosmic symbolism. The body is ruined outside the horizon, in a region that still belongs, at least in principle, to the communicative universe. If that happens, the sequence is not fully known in every physiological detail, and no serious account should pretend otherwise. Human beings have never approached such conditions, but the basic physics is clear enough. First comes increasing stress as the lower part of the body is accelerated more strongly inward. If the difference becomes large enough, tissues would begin to fail, vessels would rupture, bones would not preserve a coherent form. Any spacecraft, unless built far beyond ordinary engineering limits, would also experience violent structural stresses. The exact order in which systems failed would depend on orientation, composition,
and the mass of the black hole. The general outcome would not depend on any of those things. A steep enough tidal field erases the distinction between body and debris. Yet, there is something even stranger than violent destruction, and it belongs to the larger black holes. Increase the black hole's mass enough, and the same event horizon that looked like a death blade around a smaller object becomes comparatively gentle at the threshold. Gentle, here, is a dangerous word, because it suggests safety. There is none, but the gradient at the horizon of a supermassive black hole can be modest enough, on the scale of a human body, that crossing it would not instantly announce itself through catastrophic tides. You might pass the point of no return without any sudden pain, without any bright sign, without any sensory confirmation that a universal boundary had just slipped behind you. That possibility feels almost offensive to instinct.
We expect the most final line in nature to be marked by spectacle. We expect some last alarm, some change in texture, color, sound, or pressure. But the event horizon is not obliged to perform for the nervous system. It is a geometric condition, not a material wall. If the black hole is large enough and the environment around it relatively quiet, you may simply continue inward exactly as before. The same stars remain distorted around you. The same profound blackness fills more of the sky. Your pulse, if you still have a body capable of measuring it, may remain calm for a while longer. The universe has changed more than your senses have. This is one of the deepest forms of unease a black hole offers. A small one threatens you in ways the body can understand. A large one may permit you to keep thinking after the possibility of return has already gone. For an observer far away, this distinction may not seem emotionally important. Dead is dead, lost is lost. But from the inside, the difference is enormous. It is the difference between a catastrophe that declares itself and a catastrophe that remains quiet while it becomes complete. The first is bodily terror. The second is existential terror. The first shouts. The second whispers. As you continue the descent, the black region now fills so much of your forward view that the rest of the sky seems wrapped around it like a stretched skin of light. The curved star field no longer feels like decoration at the edge of an object. It feels like the object is dictating the arrangement of all visible things. Any asymmetry in the black hole's surroundings, any uneven glow from matter in orbit, becomes more dramatic. If there is an accretion disk, its appearance may be startlingly counterintuitive. Light from the far side can be bent over the top and under the bottom, making the disk appear to rise above the hole in places where common perspective says it should be hidden. The black hole turns simple shapes into impossible images. This is where many visualizations of black holes, when done well, feel so unnerving. They are not frightening because they are chaotic. They are frightening because they are orderly in an alien way. The light curves smoothly. The symmetries are exact. The distortions are not random, but lawful. The result is a kind of cosmic honesty that leaves no room for comfort. Everything looks wrong for a reason. Every impossible sight is a consequence of equations that have no interest in human preference. Color also begins to change in meaningful ways, though not always in ways the eye can simply enjoy as spectacle. Light climbing out of a strong gravitational field loses energy. Its wavelength stretches. This is gravitational redshift. Light moving inward toward the hole, or light observed from a frame rushing toward a bright region,
can be shifted in the opposite direction under the right conditions, becoming bluer and more energetic. Add ordinary motion to gravitational effects, and the scene becomes richer still. Parts of the universe ahead of you may seem concentrated and brightened. Others behind may dim and redden. The sky becomes not merely distorted in shape, but edited in energy. To the eye alone, some of this might present as changes in brightness more than obvious rainbows of color. Human vision is limited, and much of the important radiation around extreme environments lies outside the narrow band our species can perceive. Instruments would tell the fuller truth, but even without them, the visual world would not feel stable. Different regions of the background would no longer share a common visual logic. Light arriving from one angle has not undergone the same history as light arriving from another. You are not just looking at objects, you are looking at routes taken through curved space-time. The body, if it remains intact, is still in free fall. That means you may continue to feel curiously weightless. This seems contradictory until one remembers that weight,
in everyday experience, is usually the feeling of something resisting gravity. Standing on the ground, you feel the floor pushing against you, while gravity pulls you down. In free fall, there is no such support force. You and your vessel, if vessel there is, are following the same curved path together. Absent strong tides, there is little local sensation of being dragged downward. This is why astronauts in orbit feel weightless, and why a person falling toward a supermassive black hole may not feel the enormity of the fall in any direct muscular way. That mismatch between objective circumstance and subjective sensation matters for another reason. It means fear may not come as panic. Panic usually seeks a target, a fire to escape, a predator to outrun, a surface to grab. But a black hole, especially a large and quiet one, can deprive fear of its usual handles. There is nothing obvious to push against, no gust to brace for, no ground to locate. The body offers no simple command except to keep existing for as long as conditions permit. In that silence, thought becomes the primary medium of dread. You understand where you are before you feel it, and thought, at this stage, begins to split along a peculiar line. There is what you know you are experiencing, and there is what you know someone far away would say about it. General relativity allows those accounts to differ without contradiction. From your point of view, your own clock remains local and ordinary. Seconds pass as seconds. If you look at an instrument on your wrist, it does not suddenly decide to stutter because the universe has become philosophically dramatic. Nearby processes continue in their own frame. Heartbeats, computation cycles, mechanical oscillations, chemical reactions, all unfold according to local physics. You do not feel your own time slowing. But for someone watching from afar, using a clock far from the black hole's gravitational influence, your approach begins to look different. Signals you send outward take longer and longer to arrive. Light emitted from your ship becomes more and more red-shifted as it climbs away from the black hole. Your motions appear to slow as you near the horizon. In the simple non-rotating case, the distant observer never quite sees you cross the event horizon in finite external time. Instead, you appear to approach it asymptotically, fading, reddening, and dimming. You are not seen to plunge through a visible doorway. You are seen to become increasingly difficult to recover from the glare and redshift of the surrounding universe until you effectively vanish from observation. This is one of the most famous black hole paradoxes in popular discussion, but it becomes less paradoxical once the role of signals is taken seriously.
The distant observer is not watching your personal time directly. They are receiving light and information that must escape the gravitational field to reach them. As you get closer to the horizon, those signals are stretched and delayed. Their account is shaped by the cost of communication. Your account is shaped by what happens locally. Both are true within their own frames. The black hole does not ask the universe to choose a single theatrical version for human comfort. If you were still able to communicate outward during the later stages of your descent, the messages themselves would tell this story. You might keep speaking at a normal pace according to your own clock, yet each signal would arrive farther apart, lower in frequency, and weaker than the last. To you, nothing unusual happens to your voice inside the craft. To the listener far away, your words become drawn out into a slowing murmur, then a drift toward frequencies their ears could not hear without translation, then silence. There is something especially haunting in that image. The universe does not slam the door. It simply makes your last signals harder and harder to deliver.
This fading matters because it helps separate what the event horizon is from what it is not. It is not a magical membrane that burns everything in a visible flash. It is not a luminous shell announcing its radius. It is a causal boundary. It marks the place beyond which outward communication is no longer possible. That is why the distant account and the local account diverge exactly where they do. Once you are sufficiently near the horizon, the escape of information becomes so difficult that external description slows and weakens toward practical extinction. Meanwhile, from your own perspective, you continue into a future that the outside universe can no longer fully monitor. There is, however, a nuance that often gets lost. The distant observer does not literally watch a frozen, sharp image of you sitting forever at the horizon in some perfect cosmic still frame. Real signals become dim, red-shifted, and effectively undetectable. Astrophysical environments are not clean laboratories. Background light, accretion glow, instrumental limits, and finite observation times all matter. So while the mathematics of Schwarzschild coordinates encourages the image of eternal freezing, the physical experience for a real observer is closer to this. You slow, fade, redden, and disappear from usable sight. In practice, the black hole still takes you away. For you, though, the question remains more intimate. What does the universe look like while this separation of stories unfolds? The answer depends again on the mass and rotation of the black hole, on your path inward, and on the nature of the surrounding light. But some general themes hold. The black region expands. Light from the universe outside is compressed into an increasingly distorted frame behind and around you. If you look outward, you may see the rest of the cosmos concentrated into a shrinking patch, brighter and more crowded than common intuition expects. Inward and outward lose some of their emotional clarity. The sky is no longer a dome above a traveler. It is a map of causal possibility. Suppose once more that the black hole is supermassive, quiet enough not to destroy you at once, and that you approach more or less radially rather than with some wildly complicated orbital sweep. The event horizon then arrives not as a visible threshold, but as a moment in the mathematics of your future. You keep falling. There is still no wall. No sharp local marker tells your skin, now is the point. If your instruments are good enough and your model accurate enough, you may estimate when it happens, but estimation is not sensation. Your mind can know that a boundary of the deepest significance is near, while your body reports nothing unusual. And then, in a physically meaningful sense, you are across.
The phrase across is misleading because it suggests stepping over a painted line, but the essential truth has changed. Outside the horizon, some future-directed path still leads away from the black hole. Inside, none do. This is not a matter of engine power or courage. It is not that escape becomes difficult in the ordinary sense. It becomes impossible. In the same way, moving into your own past is impossible. The structure of the space-time has changed so that inward, toward the center, is not merely a location, but a feature of every allowed future. This idea is so strange that language keeps trying to sabotage it. We speak of the singularity as if it were a place ahead, and in one sense it is. But inside the horizon of an ideal non-rotating black hole, reaching smaller radii is more like advancing in time than choosing a destination in space. You do not decide whether to head inward any more than you decide whether to move toward tomorrow. Once inside, the center is in your future. Different paths may alter the details of the journey. None restore outward freedom. The horizon is the moment after which the word later and the word deeper begin to overlap.
This is why saying you cannot turn around is, while correct, still too weak. Turning around is an action within a space that offers multiple futures. Inside the horizon, the very menu of futures is altered. Fire your engines outward if you like. Rotate your ship. Point every remaining system at the blackness you are trying to leave behind. Locally, these actions still have meaning, but globally, they do not rewrite the causal structure. You may change how you arrive at the center. You do not change the fact of arrival. In a rotating black hole, the interior structure is more complicated. There are additional surfaces and subtleties in the mathematical description, and regions can exist where space-time itself is dragged in the direction of the black hole's spin. Outside the horizon, this frame dragging is already important near very rapidly spinning holes. Inside, the theoretical landscape becomes stranger still. But the broad lesson remains the same. Crossing the horizon is not just entering a stronger gravitational field. It is entering a region where escape is absent from the future light cone. The details of the internal architecture may vary by model. The one-way character of the horizon does not. The emotional effect of this is difficult to overstate. Human fear evolved around objects and events that remained part of a common world. A cliff threatens because both you and the cliff exist in the same arena of shared possibilities. You can step back. Someone can reach for you. A black hole horizon threatens in a colder way. Once crossed, it divides not only positions, but communicative reality. The outside world continues. You continue for a while, but the bridge between those continuities is broken in one direction forever. That is not just isolation. It is causal exile. And still, the fall itself continues with a deceptive calm if the black hole is large enough. This calm should not be confused with mercy. Tidal forces are still growing as you move deeper. What was survivable at the horizon will not remain so indefinitely. The gradient strengthens inward. A supermassive black hole can postpone the bodily violence. It does not cancel it. There comes a point at which the difference in gravitational pull across your body, your ship, or any structure you occupy becomes too great for integrity to survive. The horizon may admit you quietly. The interior eventually demands a harder payment. Before that payment arrives, however, there may be time for observation. In some idealized descriptions, you could still look outward and see light from the outside universe pouring in after you. Because of the strange geometry,
the visual world can become increasingly compressed into peculiar patterns. The rest of the universe might appear to speed up in certain respects, depending on what you are measuring and how incoming light is shifted. But one must be careful here. Popular accounts sometimes leap too quickly into claims that you would watch the entire future of the universe unfold in an instant. The real story is subtler and depends on path, geometry, and physical limitations. General relativity allows extreme distortions in received signals, but turning that into a neat human movie of cosmic history is an oversimplification. What is safer to say is that your relation to the outside universe has become profoundly asymmetrical. Light can still come inward across the horizon from outside. Light cannot go back out from you. Information from the larger cosmos may continue to reach you for a time, but your own story can no longer rejoin theirs. That alone is enough to make the interior feel like a one-sided observatory, a final chamber from which the universe is still visible in fragments, even though you have ceased to be visible to it in return. If the black hole rotates, the asymmetries in what you see can become even more dramatic. The dragged space-time, the altered photon paths,
and the non-spherical details of the environment complicate the visual map. Yet, from a documentary perspective, the important thing is not to decorate the scene with speculation beyond what physics can support. The important thing is to notice how consistently the same themes return. Light is bent, time is frame-dependent, communication outward fails. Bodily destruction depends on scale and depth rather than on the horizon as such. Every new detail refines those truths rather than replacing them. There is also a strange psychological shift that would likely occur long before any final physical breakup. Outside the horizon, danger is something you still relate to in the future tense. You may say, I am approaching a boundary. I am nearing the point of no return. I am running out of time. Inside, even if you do not feel different immediately, the grammar of your situation has changed. You are no longer approaching the trap. You are in it. Future choices still exist in a local sense, but the largest question has already been answered. There will be no return. That certainty can be more exhausting than panic. Panic spends itself in attempts. Certainty settles like a deep and silent weight. For a while, that weight may coexist with wonder. It is possible to imagine an observer in such conditions remaining intellectually alive to the scene. There is no contradiction between awe and doom. The universe does not ask you to choose. The sight of distorted starlight, of warped disks and compressed backgrounds, could remain beautiful even as it becomes useless as a guide. The experience might resemble standing in a cathedral that is also a machine for ending worlds. Grandeur and annihilation often live close together in astrophysics. This closeness is one reason black holes have become such powerful symbols in culture, though the real physics is more sober than symbolism usually allows. They represent not just death, but limits of visibility, of return, of intuition, of theory. Yet the approach to those limits is not made of arbitrary mystery. We can calculate much of it. We can test parts of it indirectly through astronomical observation. We can model the behavior of matter and light near these objects with enormous sophistication. The black hole is not frightening because science fails everywhere around it. It is frightening because science works so well up to a certain depth and then begins, with admirable honesty, to admit where its language becomes incomplete. You continue inward through that zone of partial knowledge. If your body still holds, if tidal forces have not yet dismantled the structure that carries your thoughts,
then each moment is lived in the narrowing gap between two horizons of understanding. One is the physical horizon already crossed, beyond which no signal escapes. The other is the theoretical horizon still ahead, beyond which our present models no longer speak with full confidence. Between them lies a region perhaps vast in proper time, perhaps brief depending on the black hole, where lived experience and mathematical prediction still overlap. Outside, no one can follow you now in the only sense that matters. They can model your trajectory, they can infer what should happen next, they can watch your final detectable light dissolve into red silence, but they cannot remain your audience. That role has ended. The only witness left is the one falling. The black hole turns every inward journey into a private event, not because privacy is built into the laws of nature as a kindness, but because the geometry will not permit transcripts. And the geometry, now, is directing everything. The center is no longer merely beneath you in some spatial sense. It is ahead in the logic of permissible futures. That is the profound claim at the heart of horizon physics. Outside, gravity influences trajectories. Inside, it reorganizes destiny.
A person can still imagine turning back, because imagination is slow to surrender its habits. Physics is under no such obligation. It has already moved the center from possible destination to unavoidable endpoint. There is a final cruelty in how quiet all of this can remain. No cosmic siren marks the shift from maybe to never. No flare of light distinguishes the last outward capable moment from the first inward only one. To the senses, the universe may still feel like a place. To the equations, it has become a funnel of futures. The difference between those descriptions is not a flaw, it is the experience itself. One useful way to understand the horizon is to imagine sending out a beam of light at regular intervals as you fall. Far from the hole, a beam aimed outward does what common sense expects. It travels away from you, widening the distance between sender and signal. Closer in, that outward light still escapes, but less efficiently, in the sense that it must climb through a stronger curvature of space-time. At the horizon, in the idealized, non-rotating picture, an outward-directed light beam no longer gains the separation from the hole that you would normally call escape. Inside, even light aimed outward is carried inward in the larger geometry. This does not mean light forgets how to move at light speed locally. It means that the directions available to future moving things have all tilted toward the center. That tilt is difficult to picture because we are used to imagining speed as the universal answer to confinement. If something can move fast enough, we think, perhaps it can outrun the trap. But the event horizon is not a prison of insufficient speed. It is a prison of structure. Light already moves as fast as anything can. If light cannot get out, then the problem is not that light is weak. The problem is that all future directed routes from that region remain trapped inside the region. This is why black hole language often sounds more like geometry than like battle. You do not defeat an event horizon. You discover too late that the map itself no longer contains the road you wanted. Before crossing, there is still the theoretical possibility of hovering above the hole, but even that reveals how unusual the place is. To remain fixed at a constant radius outside a black hole requires acceleration. Near the horizon, the required acceleration rises without bound in the idealized picture. A ship could orbit, yes, or free fall inward, but to hover motionless just above the boundary,
like a helicopter above a cliff, would demand more and more thrust as the radius shrank. This is another way of seeing that the horizon is not an ordinary surface in space. It is not a doorstep at which you can comfortably linger. The closer you try to hold position without falling, the more violently the universe insists that such stillness does not belong there. And so, free fall remains, in a way, the gentlest available path toward a place that is not gentle at all. In free fall, you are not fighting the geometry, you are consenting to it, or perhaps being carried by it. This is why the local experience near the horizon can remain so deceptively smooth. According to general relativity, a freely falling observer crossing the event horizon of a sufficiently large black hole should, at that moment, encounter nothing singular in the local laws of physics. Spacecraft instruments measuring nearby conditions may detect no sudden jump, assuming they are not overwhelmed by external radiation or later by tides. The horizon is globally decisive, yet locally understated. Many coordinate systems used by physicists reflect this subtlety. In some coordinates, the horizon appears pathological, as if time itself stops there. In others, the mathematical description passes smoothly through. This is not because one set of equations is dramatic and another is merciful.
It is because coordinates are descriptive tools, and some tools become awkward at certain boundaries. The physical content lies deeper than any single chart. The useful lesson for a falling observer is simple. The horizon is real, but the drama surrounding it often comes from the way we choose to describe space-time, not from fireworks nature is obliged to provide. Even so, description matters because it shapes what can be imagined. Popular stories often ask whether the falling person is crushed at the horizon or whether they live forever from their own perspective. Neither picture is quite right as a universal rule. The fate depends on the black hole's mass and internal structure, and living forever is not the promise of any realistic descent. Proper time inside the hole remains finite before deeper regions are reached. The horizon is not immortality, it is transition. A small hole makes that transition physically brutal early. A large hole can let it remain conceptually brutal first. If you had a window and the courage to keep looking through it, the visual world after the crossing might still seem outwardly continuous for a time. The same distorted stars, the same warped glow from any surrounding matter, the same darkness ahead. Yet the meaning of every visible thing has changed. That field of stars beyond the rim is now not just scenery, it is the unreachable outside. The horizon has turned the universe into something you may still see, but can no longer rejoin. There is a loneliness in that, which goes beyond isolation between people. It is isolation from causality, as it was once shared. A distant civilization, if one happened to be observing with impossible patience and exquisite instruments, could continue calculating your fate long after direct contact was lost. They might know the black hole's mass to many decimal places. They might map the spin, model the accretion flow, estimate the proper time you had left after the crossing. But none of that restores reciprocity. Knowledge from outside is no longer conversation. The black hole reduces all rescue plans to historical fantasies the moment the horizon is passed. Even if the entire galaxy agreed on the importance of saving you, agreement would change nothing. There are corners of physics where collective will is irrelevant. This indifference is worth emphasizing because it separates black holes from ordinary disasters. Most catastrophes remain, at least in principle, open to intervention. A storm can be fled, a famine can be relieved, a collision course can be altered if seen early enough.
A black hole certainly allows intervention before the final limit, but after that limit, it ceases to care about resources, technology, or moral urgency. The event horizon does not respond to need. It simply marks where outward causation has ended. In that sense, it is one of nature's purest examples of finality. Yet, finality does not mean immediate darkness in the mind. If you are still intact, thought can continue, and thought has a peculiar property under extreme circumstances. It reaches backward. It compares. It tries to assemble order from scales the body never evolved to face. Perhaps you think of Earth, where gravity was once the weight of your own limbs and the familiar fall of objects from a table. Perhaps you think of how mild and domestic that word gravity sounded before this. On worlds and moons, gravity is environment. Here, it is architecture. It builds not just motion, but the terms under which motion can be discussed. By now, the idea of up and down may have become almost useless, except as a courtesy to language. The center is the only meaningful inward direction, yet even that can be misleading if imagined too literally. There is no shaft through the black hole interior like a tunnel drilled through rock. There is curvature, finite proper time, and the eventual growth of tidal stress. In a rotating hole, the paths can be more complicated,
And the mathematics permits structures that have inspired decades of speculation. But speculation must be handled carefully. Theories extending through inner horizons, ring singularities, or bridges to other regions of space-time belong to mathematical possibilities under idealized conditions. Whether nature permits such structures in a form any real infalling object could experience is another question entirely. Soon the question will narrow again, away from horizons and toward survival itself, because the quiet entrance cannot protect you forever. Soon the question will narrow again, away from horizons and toward survival itself, because the quiet entrance cannot protect you forever. The deeper you go, the less important the horizon becomes as a dramatic idea, and the more important gradients, timescales, and broken structures become as physical facts. A supermassive black hole may allow you to cross the boundary with deceptive calm, but it does not offer indefinite grace. The space inside is still falling inward, still tightening, still carrying every future toward a center that no living body was ever meant to approach. How long remains depends first on the size of the hole. That is one of the gentler truths hidden inside a brutal subject. The larger the black hole, the longer your remaining proper time can be between the horizon and whatever deeper region ends coherent survival. In the case of a stellar mass hole, that interval can be very short. In the case of a supermassive one, the journey inward can be long enough for thought, observation, and perhaps a terrible kind of patience. This does not mean long in the everyday sense of comfort. It means only that nature sometimes chooses duration over immediate violence. Proper time matters here because it is the time measured along your own world line, the time that still belongs to your experience. Outside the hole, distant observers lost the ability to follow you in a shared way once signals failed to escape cleanly. Inside, only your own clock remains relevant to your story. If there were instruments still functioning, they would not speak of eternity. They would register a finite interval. General relativity, at least in the classical picture, does not offer an endless drift within an ordinary black hole interior. From the horizon to the singular endpoint, the future is finite. This finiteness gives the interior a curious emotional shape. It is not an endless prison in the mythic sense, where consciousness is left to wander forever in darkness. It is a corridor, though not one built of walls. It has no turns that return to daylight. It has no side doors, but it has a length. Something still unfolds there. The last act of the fall is not a static state. It is a progression toward stronger curvature, stronger tides, and more extreme limits on what matter can remain matter for. By now, if the black hole is large enough that your body survived the crossing, the first changes inside may still be subtle. Yet, subtlety is only another way of saying that the final violence has not reached its full strength. The gravitational difference between one end of your body and the other continues to grow as the radial coordinate shrinks. Structures that were still within tolerance nearer the horizon begin to accumulate stress. If you are inside a craft, that craft now faces a test no aerospace engineer designs for. Every beam, every fastener, every seal must answer not merely to acceleration, but to differential acceleration. Parts of the vessel closer to the center are invited into a slightly different future than parts farther away. Engineers on Earth think deeply about vibration, fatigue, thermal expansion, torsion, and resonance. Those are the normal languages of structural failure. Inside a black hole, the language becomes more primitive.
It is less about whether a design is elegant and more about whether a single connected object can continue behaving as one object when space-time itself is varying too strongly across its length. The answer is always temporary. Some materials last longer, none last forever. There is no alloy for absolute curvature. If there were still windows or screens translating radiation into visible form, you might continue to look outward even as the interior mechanics of your craft begin to complain. The outside universe would not vanish in a theatrical blink. It would remain visible in the one-sided way already established. Light can still come in. Information from the cosmos can still enter the whole. But what that light means becomes harder to interpret. Angles are no longer familiar. The distribution of brightness may change in strange ways. What was once the sky has become a distorted inheritance from a realm you no longer share. There is a temptation in popular storytelling to turn this inward journey into pure fantasy at exactly this point. Once the horizon has been crossed, many accounts feel licensed to say almost anything. You will see the entire future of the universe. You will emerge in another cosmos. You will pass through a hidden gate. You will be copied into a white hole. Such ideas are alluring, partly because they rescue the imagination from the severity of the classical picture. But severity is not a flaw in the subject. It is one of the reasons black holes are scientifically and emotionally important. They lead thought to a place where the known laws still speak, but their voice becomes narrower, colder, and more exacting. So the more careful question is not what wondrous thing fiction would like to happen next. It is what our best present understanding still permits us to say with honesty. Classical general relativity describes the interior trajectory toward a singular conclusion. It tells us that curvature grows. It tells us that finite, proper time remains. It tells us that the horizon is not a local drama, but the singularity, in the mathematical sense, is a place where the classical description runs out. What it does not yet give us, at least not in any completed and experimentally confirmed way, is a final quantum account of what replaces that singular breakdown. This distinction matters because the word singularity has been burdened with too much mythology. In the equations of classical relativity, it is often described as a place where densities and curvatures become infinite. Infinity, in physics, is usually not an achievement of nature. It is a warning sign in the model. It tells us that we have driven a successful theory beyond the range where it can remain complete. General relativity is magnificent, but it is not expected to be the last word at arbitrarily small scales and arbitrarily strong curvatures. Quantum physics must matter there. Yet no fully accepted quantum theory of gravity has been confirmed to tell the ending cleanly. That means that, as you continue inward, the story enters an unusual zone. The outer parts of the journey were supported by strong theory and indirect evidence. The inner parts are supported by extrapolation from that strong theory into a region where we expect it to become incomplete. This does not mean that everything becomes guesswork at once. It means the confidence gradually changes character. We can be confident that the horizon is real in the sense already discussed. We can be confident that tides deepen inward. We can be confident that a final regime is reached where classical notions fail. The precise nature of that regime is what remains open. There is something almost tender in that scientific restraint. The black hole is one of the few places where modern physics, so often praised for its reach, is forced into a tone of humility. It can describe the geometry around the abyss with astonishing elegance. It can predict lensing, redshift, orbital motion, accretion behavior, and wave signals from colliding holes. It can even map the local experience of a falling observer with considerable rigor through much of the descent. Yet, when it approaches the ultimate interior, it does not pretend to know more than it does. The equations begin to sharpen toward a kind of silence. Before that silence arrives, however, bodily reality returns to the foreground. However calm the crossing may have been, however long your proper time inside a giant black hole may be, the growing tidal field is relentless. The difference in pull across your body continues to intensify. The scale at which it becomes intolerable depends on the black hole's mass and on how close to the center you have come, but the direction of change does not depend on hope. It only depends on depth. What the small black hole threatened early, the giant black hole threatens late. This late violence carries its own emotional tone. Outside the horizon, and even at the horizon in a supermassive case, the mind could still occupy itself with geometry, with paradox, with the elegance of bent light and diverging clocks. Deeper in, thought is drawn back toward the body. Differential acceleration no longer feels like an abstract concept in a textbook. It becomes strain, stress, distortion, and the breaking of any assumption that the body will remain a single, calm platform for consciousness. The universe, having first challenged your understanding, now challenges your composition. In such a setting, ordinary categories start to fail. Where exactly does the self reside when different parts of the body are being driven into different motions? Neuroscience, in ordinary conditions, already struggles to reduce identity to a simple location. A black hole interior adds a cruel physical twist. The brain, too, is extended matter in a tidal field.
There is no reason to imagine that consciousness would remain immune while the tissues supporting it undergo growing differentials of force and time. We do not know the exact experiential sequence because nothing like this has ever been observed in a living organism, but we know enough to avoid comforting illusions. A coherent self depends on coherent physical support. This is one reason the thought experiment remains so powerful, even though no person is likely to undertake it. Falling into a black hole is not only a question about death,
It is a question about which structures in nature are gentle enough to host a mind, and how those structures fail under extreme curvature. Black holes expose the dependence of thought on conditions that everyday life lets us ignore. We think of the mind as airy, inward, separate from mechanics. A black hole reminds us that every thought was always held inside matter, under law. There is another timescale moving quietly beneath all this, the lifetime of the black hole itself. It is natural to wonder whether the hole might somehow fade before you reach the end. Hawking radiation, the theoretical process by which black holes can slowly lose mass through quantum effects near the horizon, has become famous enough that many people know the phrase, even if they do not know the details. In principle, black holes are not perfectly eternal. In principle, they can evaporate. But principle and human relevance are not the same thing. For black holes of astrophysical size, the evaporation time is fantastically long, far beyond any interval meaningful to a falling observer. This is another case where the truth is more sober and more impressive than the myth. Yes, black holes can radiate. Yes, over unimaginable spans, they may lose mass and eventually disappear, but not on your timescale. Not on the timescale of a human life, or a civilization, or even many cosmic epochs as we usually discuss them.
A large black hole does not save you by fading away beneath you. It remains, for all practical purposes, exactly what it was when you crossed the horizon, a long-lived region of one-way geometry that will outlast every personal story by a margin so enormous it barely fits into language. That fact changes the feeling of the descent yet again. If the black hole were some brief cosmic weather event, its power would feel contingent, accidental, perhaps almost negotiable. But a black hole's durability gives it a different presence. It is not a flash. It is architecture on deep time. It can sit in the heart of a galaxy for ages beyond ages, shaping stellar motions, regulating energetic outbursts, sometimes feeding, sometimes sleeping, always preserving its central authority. To fall into such an object is not to be consumed by a passing violence. It is to enter one of the universe's most enduring institutions. Around supermassive black holes, entire galactic histories have unfolded. Stars have formed, aged, exploded, and been replaced. Gas has rained inward in some eras and thinned in others. Galaxies have merged, and their central holes have spiraled toward one another, sending gravitational waves across space when they finally joined. The quiet blackness you entered has likely outlived forms of matter, arrangements of stars, and perhaps biological possibilities on worlds that came and went unnoticed. This does not make your fall less tragic. It makes it less central. The black hole is not a villain that waited for you. It is a long-lived feature of a cosmos where your arrival was local and brief. There is a calm in accepting that scale, though it is a severe calm. It asks the mind to stop treating itself as the measure of the scene. The black hole is not made more real by your fear, nor made less real by your absence. It simply is. This indifference can sound bleak when phrased too sharply, but there is another way to hear it. The universe does not single anyone out. Not for rescue, not for punishment. A black hole is not cruel by intention. Its cruelty is structural. That distinction does not help the falling observer survive. It does, however, place the event inside a broader honesty. Nature does not hate you. Nature does not know you. It only continues. And still the question that opened this long descent deserves its cleanest answer.
What if you fell into a black hole? If the black hole were small enough and your path close enough, tidal forces would likely destroy your body before you even reached the event horizon. If the black hole were actively feeding, radiation and the surrounding furnace of infalling matter might kill you earlier still. If the black hole were supermassive and comparatively quiet, you might cross the horizon without any immediate sensation marking the moment. You would continue inward for a finite interval of your own time. Outward communication would be lost. Tidal forces would grow stronger. Eventually, under the classical picture, no coherent physical structure, human or mechanical, would survive the journey toward the central breakdown of the theory. That is the answer science presently allows with the greatest confidence. It is not a portal story. It is not a guaranteed vision of another universe. It is not a neat cinematic death at the horizon itself. It is a layered sequence in which the details depend on scale and environment, but the broad direction does not. There is approach, distortion, causally significant crossing, and eventual destruction. Beyond that destruction lies a region where our current descriptions no longer speak with final authority. The mystery is real, but it begins after the certainty of doom, not before it. This may seem at first like a disappointing answer. Human imagination often wants an exchange. If we are to approach something so extreme, perhaps we should at least be rewarded with revelation. Perhaps the black hole should show us the future of the universe,
or the hidden machinery beneath reality, or some shimmering bridge to elsewhere. Yet, there is another way to understand what the thought experiment has already revealed. It has shown us, with unusual clarity, how space and time can cease to be the stable stage we take them for. It has shown us that seeing is not always knowing, that survival depends on gradients we do not feel in daily life, and that the universe contains places where causality itself acquires a direction as final as stone. In that sense, the black hole has already given a revelation, only not the sentimental kind. It reveals that the world is stranger than the categories built by ordinary survival. Most of life happens in gentle curvature. We wake under stars that seem fixed, on a planet whose gravity is strong enough to hold us, but weak enough to let our bodies remain bodies, our clocks remain roughly shared, our communication remain open, our futures branch in many directions. A black hole shows what happens when that gentleness is removed. It is not another world in the science fiction sense. It is the same universe under a far harsher interpretation. This harshness tells us something important about the rest of the cosmos. The everyday world is not dull simply because it is familiar. It is extraordinarily permissive. Earth allows oceans to remain oceans, atmospheres to remain atmospheres, cells to remain cells, and minds to remain coherent over decades. Our local corner of the universe is not normal in any universal sense. It is hospitable by a set of conditions so specific that only by imagining their destruction do we begin to understand their value. A black hole is the opposite of a habitat. It is a demonstration of how much must be true for a habitat to exist at all. There is also a lesson here about scale and contingency. The same gravity that keeps planets in orbit, guides tides, shapes stars, and organizes galaxies can, under sufficient concentration, create the black hole. The universe does not switch from one set of laws to another when it becomes dramatic. It continues the same laws into more severe regimes. That continuity is part of the beauty. The abyss is not magical. it is lawful. A black hole is made from the same gravitational principle that once kept your childhood world intact beneath your feet. The terror comes from the principle remaining faithful to itself when faithfulness becomes extreme. Perhaps that is why black holes unsettle even people who know the equations. They are not monsters imported into nature from outside. They are natural consequences drawn from the logic of mass, curvature, and collapse. They belong, and because they belong, they force a humbling thought. The universe was never organized for the convenience of human intuition. It merely allowed, in some regions and for some spans, the growth of beings capable of asking questions before sleep. Black holes remind those beings that asking is not the same as mastering. As the journey nears its deepest silence, the scientific and the meditative begin to draw closer together. This often happens at the edge of difficult truths. Precision, pursued far enough, returns us to wonder, not because the equations become vague, but because they become so exact that the mind sees how little of reality was ever built around its comfort. In a black hole, the geometry is exact. The consequences are exact. Our incompleteness in describing the final interior is also exact in its own way. The combination is not a defeat. It is a form of honesty large enough to be beautiful. Imagine now the outside universe not as a collection of places you might one day return to, but as a distant lantern of everything that once felt shared. Galaxies still turn. Stars still burn hydrogen into light. Planets still carry weather, ice, dust, rain, perhaps life. None of that stops because one object fell beyond one horizon. The black hole does not interrupt the larger cosmos. It only severs your line back to it. This is part of what makes the whole question feel so intimate, despite its cosmic scale. The universe remains full, but your participation in it narrows to a one-way reception, then, eventually, to nothing we know how to describe. And yet, even that narrowing has a kind of grandeur. To fall into a black hole is to encounter one of the universe's clearest statements that time is not merely a background clock ticking identically everywhere. It is woven into structure, affected by mass, path, and depth. Near Earth, we can ignore that truth most of the time. Near a black hole, we cannot. The thought experiment makes visible something that is always true, but seldom felt. Time was never universal in the simple sense. It only felt that way because our world is gentle enough to hide the differences. There is a similar lesson about light. We often think of light as honest because it lets us see, but near a black hole, honesty becomes complicated. Light still obeys the rules. It still carries information faithfully along the paths space-time permits. Yet those permitted paths can be so contorted that the scene becomes almost impossible to interpret without theory. This does not make light dishonest. It makes seeing humble. Observation alone is not enough when geometry itself has become unfamiliar. Meaning must be earned. All of this returns, quietly, to the fragile condition of being a human observer at all. A person is a local arrangement of matter maintained in narrow environmental limits on a small world around an ordinary star in the calm outskirts of a galaxy that also contains, near its heart, a supermassive black hole. The contrast is almost absurd. On one scale, you are warm blood, memory, breath, and sleep. On another,
You are a transient arrangement inside a universe capable of making regions where even light can no longer report outward. To hold both truths at once is not to diminish the human scale, it is to locate it.
And locating it has a soothing effect if one lets it. Not because the black hole has become less severe, but because the mind has stopped demanding that severity be translated into human terms of fairness, reward, or narrative closure. The black hole does not need to mean more than it is. Its reality is enough. A concentration of mass, a boundary of causality, a region where our strongest theories are pushed toward their limits, a patient dark at the center of motion and time. In acknowledging that, the struggle to turn it into myth begins to soften. Softening is not forgetting. It is allowing the scene to remain vast without insisting on panic. The stars that once bent around the blackness are still there in imagination now, though farther away. The luminous ring, the warped background, the quiet crossing, the one-sided signals, the growing tides, the finite inward time, the unanswered question at the deepest core, each part belongs to the same long movement. What began as visual confusion became physics. What became physics became inevitability. What became inevitability has now become reflection. Reflection, too, has its gradients. At first, it asks practical questions. What kills you first? How long do you have? What does the outside observer see? Then it asks larger questions. What is a horizon, really, if nothing marks it locally? What is the self, if thought depends on matter under law? What kind of universe produces places like this? In the end, the largest questions become almost simple. How strange is reality, that it permits both sleeping oceans under moonlight and black holes at the hearts of galaxies? How gentle is our daily world, that it can make us forget the severity from which it is built? A black hole does not answer those questions in words. It answers them by existing. That may be why it lingers in the human imagination, not because anyone expects to fall into one, but because it sits at the meeting point of many things we instinctively separate. Beauty and danger, law and mystery, precision and silence. It is a natural object that behaves like a philosophical argument. It tells us, without intention, that the universe is under no obligation to remain intuitive as it becomes profound. If you let that thought settle, the fear loosens a little. Not because the black hole has become kind, but because the mind has stopped trying to force it into smaller shapes. The darkness at the center of the story becomes simply one more form the cosmos can take when gravity is allowed to speak without compromise. There is no hatred in it, no urgency, only concentration, curvature, and time directed inward. It is terrible, yes, but it is terrible in the same way a mountain storm or a deep ocean trench is terrible, by being entirely itself, beyond the scale of your wishes. And then, as often happens in long contemplation, the subject begins to widen again. Beyond the black hole, there is the galaxy holding it. Beyond the galaxy, there are other galaxies, each with their own histories of star birth and collapse, mergers and quiet ages, some with bright feeding nuclei, others with sleeping setters. Across the observable universe, black holes of many sizes persist, not as exceptions to cosmic order, but as expressions of it. They are woven into the life cycles of stars and the architecture of galaxies. Even their collisions can shake space-time itself, sending gravitational waves outward like faint signatures of invisible violence. Those waves have reached us.
Instruments on Earth, delicate enough to sense distortions smaller than an atomic nucleus across enormous arms of laser light, have heard black holes merge. That fact alone feels almost dreamlike. On a small planet around an ordinary star, a species made of soft tissue built devices capable of measuring the ringing of space-time from remote collisions of collapsed objects. Perhaps that is the final balance of this story. The universe is severe enough to make black holes.
It is also permissive enough to make beings who can know that black holes are there. Knowledge does not protect us from every consequence of nature. It would not save you inside the horizon once the future had narrowed to one direction, but knowledge changes the texture of our relationship to the cosmos. It allows a black hole to become more than fear. It becomes perspective, a measure of how far theory can reach, how strange ordinary reality already was, how small and how remarkable consciousness is. To understand that even partly is not a poor substitute for safety. It is one of the few forms of grace physics offers. Now the images can grow quieter. The bent stars no longer need to be frightening. They can simply arc around the black center in the mind, each line of light following the curve permitted to it. The horizon can remain invisible, as it always was, not because it hides maliciously, but because some of the deepest boundaries in nature are not painted on surfaces. They are written into what futures are allowed. The accretion glow, if there is one, can soften into a distant ring, a furnace seen from the edge of thought rather than from the urgency of survival. The black hole can return to being what it was at the beginning, a region of silence so complete that even light must negotiate with it. And far away from that silence, worlds continue under simpler gravities. Seas rise and fall. Clouds travel over continents. Night arrives over towns, forests, deserts, and coasts. Somewhere, someone looks up at a dark sky and sees starlight that has crossed impossible distances without knowing how easily those paths could have been bent elsewhere. Somewhere else, a galaxy turns around its hidden center, carrying bright dust lanes and patient stars around a darkness no eye can see directly. The universe does not stop because it contains abysses. It deepens. So if the thought remains with you, let it remain gently, not as a nightmare of being torn apart, though that possibility belonged honestly to the story. Not as a fantasy of secret doors beyond the horizon, though imagination will always be tempted by them. Let it remain as a vast and quiet realization that reality is larger than the scales on which life learned to feel at home. There are places where space folds light, where time divides into different accounts, where return ceases to exist as an option, and where our finest theories walk with confidence until they reach a final dark and fall silent. That dark is not empty. It is full of implication. It tells us that the cosmos is capable of elegance severe enough to frighten and beauty precise enough to soothe. It tells us that limits are part of understanding, not enemies of it. It tells us that a human mind, brief and local as it is, can still lean toward the strangest places in the universe and come back, not physically, but thoughtfully, carrying a clearer sense of the world it already lived in. And that may be the quiet answer waiting underneath the question. You do not need to fall into a black hole to be changed by one. It is enough to imagine the descent carefully, honestly, and long enough for the everyday world to reveal its own improbable gentleness by contrast. The floor beneath you, the air around you,
the shared clocks of ordinary life. The fact that light from the stars can still reach your eyes without being torn into impossible curves. These are not small things. They are the conditions of a mild universe, or at least of a mild corner within a severe one. The rest can drift outward now. The instruments can dim. The equations can recede into their calm symbols. The black circle can remain suspended in the mind's sky, surrounded by its faint, curved border of borrowed starlight. No alarm, no motion you need to resist, only distance, quiet, and the knowledge that somewhere beyond sleep, galaxies still turn around hidden centers, and light still travels until gravity teaches it another path.
Let the stars straighten again if they wish. Let the darkness remain where it is, patient and far away. Let the modern world grow lighter at the edges, then softer, then less necessary. There is still a universe beyond these words, immense and largely silent, holding oceans, mountains, storms, fossils, forests, moons, deserts, ice, deep time, and also the black holes that remind all those gentler things how rare they are. There is one more reason the final uncertainty matters, and it has to do with the difference between mystery and permission. When people hear that physics becomes incomplete near the singular end point, they sometimes assume the door has been opened to any story they prefer. But an incomplete theory is not a blank check. It is a boundary on confidence. We know that quantum gravity, whatever its final form may be, must reduce to the tested successes of general relativity, where relativity already works. We know that any deeper account must still respect the immense body of evidence gathered outside black holes in cosmology, particle physics, and gravitational observation. So, while it is fair to admit that the innermost fate is not yet fully described, it is not fair to convert that admission into unrestricted fantasy. The unknown is disciplined by everything we already know. That discipline is itself part of the beauty. Science is often imagined as a machine for turning darkness into daylight, as if every unanswered question simply waits for a lamp. But black holes suggest a subtler image. Sometimes science maps the darkness without pretending it has already illuminated the center. It marks where the last reliable measurements stand. It traces the curvature of the ground leading inward. It tells us how far our tested language reaches and where new language must eventually be built. In that sense, the singularity is not just a physical idea. It is also a mirror held up to human understanding. It shows us the exact point where confidence ends and responsibility begins. If there is comfort in that, it comes from the fact that uncertainty here is not ignorance in the crude sense. We are not lost in superstition. We are standing at the edge of a remarkably coherent account of nature, looking into the place where coherence must deepen or change. The black hole becomes, then, not only an object of fear, but a frontier for thought. Its existence links stellar death to galactic history, relativity to quantum questions, visible astronomy to invisible structure. It is a place where many parts of physics meet and fail to fully merge, which is precisely why it remains so compelling. To contemplate a black hole is to contemplate both the success and the incompleteness of the human effort to understand the world. Perhaps that is why the image of falling into one lingers so powerfully. The descent is physical, yes, but it is also intellectual. At first, you lose ordinary visual certainty,
Then you lose the common logic of time shared with distant observers. Then you lose the possibility of return. Finally, theory itself begins to lose its clear footing. The journey inward is also a journey through layers of explanation, each one deeper, each one more exacting, each one revealing how much of reality can be known, and where knowledge must, for a while, become wonder. And even there, where equations thin and language softens, the universe remains consistent with itself, vast enough to exceed us, orderly enough to keep inviting thought inward still. And in that greater silence, the abyss continues without needing witness, while the stars go on bending, and the night goes on widening, and the cosmos, vast and indifferent and beautiful, remains awake.